All right, if we're going to find the derivative, taking the limit as h approaches 0, apply to the difference quotient, we start with what f of x plus h is. We go up to the function as it's defined, we locate our x's. Wherever we see our x's, we're going to plug in x plus h. So we carry this step down. We've got the limit as h approaches 0. We're taking this f of x plus h expression out. We're replacing it with 2 over the square root of 3 minus, substituting x plus h in the place of x. It'd be a quantity of x plus h that I'm subtracting there. So you got to be careful with how you're grouping it. Continuing with the difference quotient up here, we subtract. We subtract what f of x is. F of x is the original function, which is 2 over the square root of 3 minus x. And that is all over h. So in simplifying this, we got a lot going on. One of the things we have going on is we got this fraction within a greater fraction idea. So I'd like to clear that out. So what I'm going to do is I'm going to multiply both the numerator and denominator by this little grouping here of denominators. See, if I do that, bring my limit down here to the next step. Let me focus in on the denominator part right now. If I know I'm multiplying by this denominator and this denominator top and bottom, well, on the bottom I'd have h times the square root of 3 minus that quantity of x plus h times the square root of 3 minus x. Right? That's all multiplied out down here. But the idea is if I multiply this little grouping here to the numerator, these fractions cancel out, and to figure out what's left, all I have to do is a little trick of cross multiplication, right? I'm going to take 2, multiply across its diagonal down here the square root of 3 minus x. We've got subtraction involved, right? So minus. Multiply across the other diagonal, you've got 2 here times the square root of. Over here I've got 3 minus that quantity of x plus h. So you know the fractions are being cleared. You just cross multiply as the trick to figure out what's left. Okay, now I notice with what's left here in my numerator I've created, there's a factor of 2 shared between each of these terms. So I'm going to factor this 2 out. Not that that's 100% necessary to do. But if I do that, then I look at what remains, and what remains, I've got a root minus a root, right? And here's a limit problem that's got roots in it. So anytime we do a limit problem that's got roots in it, what do we use? Yeah. All right, we're going to use the conjugate of the numerator expression. So the conjugate would be the square root of 3 minus x plus, going to run out of room here, the square root of 3 minus the quantity x plus h. All I'm changing is that sign in between, right? This is minus over here, this is plus over here. Multiply the same thing to the denominator. Got square root of 3 minus x plus square root of 3 minus that quantity of x plus h. Looks like a train wreck, doesn't it? But we know if we multiply conjugates out, we're just multiplying the first and the last. We've always got these roots that are the same, and these roots are canceling out, right? So if I write what remains here, starting with the numerator, you got this factor of 2, don't forget about that. But multiplying across the conjugates, multiplying these first terms, those roots disappear, you're left with 3 minus x, right? So it's 2 times this quantity of 3 minus x so far. We multiply across the last terms, understanding we will be subtracting this result because the negative times the positive. But multiplying across the last terms, these roots would cancel, right? And you'd be left with a quantity of 3 minus a quantity of x plus h. This problem's not ridiculous, is it? Got enough parentheses in here? Nope, need another one. But that's my result that's left on the numerator. In the meantime, in the denominator, the rule is when we're working with conjugates, only multiply the conjugate portions together, right? Leave the other part alone. And thank goodness we're leaving the other part alone. We're just bringing it down here. We don't want to multiply this all out anyway. That's a lot of writing. Let's go through, though, and do some simplifying now in the numerator. In the numerator, I've got some negatives to carry through, don't I? Starting with my innermost parentheses, working my way out. Let's see, I've got an x plus h in here. I got a negative applied. So if I carry that negative through, it makes those negative, right? But what here is interesting is you've got a negative right here that you got to distribute through, right? So if I distribute that through, it changes these signs back. It's craziness. But now I'm at the point where at least inside here, it looks like I've distributed everything I can, and I can start collecting like terms, right? So let's see what happens. You've got a couple of 3's that cancel out, don't they? You got a couple of x's that cancel out. What's left? It's just 2 times h, right? So all that's left is 2 times h, 2h. If that's what's left in the numerator, since we didn't multiply everything out in the denominator, we got this factor of h down here we can use, right? So if this is 2 times h, as long as it's being multiplied, we can cancel these h's out, meaning all that's left in the numerator is a 2. So let's kind of reassess where we're at right now. Scroll down here a little bit. Taking the limit as h approaches 0. Limits still apply here because we haven't cleaned up our mess. We haven't simplified. We've got a 2 over, bringing this other stuff down. Now it's simplified. Since we finally simplified it, we can apply this limit. We know h is approaching 0. So wherever we see an h, we're going to plug 0 in its place, meaning we got what left over? We've got 2 over. Let's see, if this h goes to 0, you're left with the square root of 3 minus x times the square root of 3 minus x. And over here, you've got the square root of 3 minus x plus, this h is going to 0. That's the square root of 3 minus x. So we're adding the square root of 3 minus x and the square root of 3 minus x, meaning we've got 2 square roots of 3 minus x. I don't see us making any algebraic mistakes on this. Just doesn't seem possible. It's too easy, right? I'll be honest with you, I'm throwing a party for you if you get to this point and you got that right. I'd accept that as an answer. But we could still do better. See, this 2 here is being multiplied to this, multiplied across, right? So these 2's technically cancel out, leaving you with 1 on top. And you've got 1, 2, 3 roots that are the same. Right? You're multiplying across those. So basically you've got 3 minus x because that's what I'm applying the root to on all these. If you think about what the square root of 3 minus x means, some of us are allergic to this problem, it sounds like. We're taking 3 minus x, raising that to a power 1/2, right? That's what that means. So my bases here of 3 minus x are all the same across. If I add my exponents as my rule, 1/2 plus 1/2 plus 1/2, I get a power of 3/2. And there's my answer. It's as simple as that.